SWEP is a global manufacturer of breastplate heat exchangers with production facilities in 5 countries. Our heat exchangers optimize the use of energy, material and space to make the world's most efficient heating and cooling systems available. We at Slovakian factory run a 24/7. The importance to minimize interruptions and downtime is paramount. One of our tools is the daily management board where we track data and assign action items to improve. At the beginning of March 2016, we observed that our throughput was trending negatively. This was due to machine breakdowns. Our Pareto analysis pointed the press line cell 3 as our number one offender. To tackle this, a PDCA team was formed in the maintenance department. We found that in the month of March, press line cell 3 had 63 stops related to stacker. The standard is to have 0 stops. We set a goal of reducing stops related to stacker to less than 31 stops by 30th of June 2016. The project team held a brainstorming session with all relevant people from several departments. We identified the top 5 potential root causes. Our first hypothesis: if preventative maintenance is performed and we replace the worn parts, we will reduce the number of stops related to the stacker. Once we reviewed the data, we learned that we needed to change our bearings on the step feeder and stacker. We also decided to set the preventative maintenance plan for this replacement for a yearly interval. After the worn parts were changed, we saw dramatic improvement. Second hypothesis: if we train the group leaders on how to reset the exchanger, we will reduce the number of stops related to the stacker. Operators cause collisions by incorrect press line handling and thus causing serious mechanical damage. We did an audit and had many discussions with operators. Based on their answers, we decided to do proper training with full explanation. Third hypothesis: if we train the service technicians to save recipes with the updated corrections, we will see a reduction in stops related to the stacker. Through our audits, we found that the service technicians' change were not being saved into the machine recipes. We have trained all service technicians on their monthly maintenance meeting, making them understand what was the result of not saving the corrections into the programs. Fourth hypothesis: if we set the ZB1 position to factory 0 position, we will reduce the number of stops related to the stacker. A few years ago, there was a project focused on improving the throughput of our existing line. After the analysis, the stacker was found to be the slowest part of the press line. As a countermeasure, the Z-axis was lowered to gain a few milliseconds per cycle. After some investigations, our team decided to return the ZB1 axis to its original position. Because of this change, it has almost been a year since we have had collision due to this issue. Our last hypothesis was: if we adjust the belt, we will achieve less stops related to the stacker. Even though it was brought up in our fishbone event, we found that the belt adjustment does not play a factor in stopping the stacker. During the month of May, we started all our hypothesis tests, but we did not hit our goal of less than 31 stops in the month of June. We found we had a problem with the main hydraulic piston seals. This caused the main slide to start sinking. After resolving problem with sinking slide and adding it to our preventative maintenance plan, we decreased quantity of breakdowns immediately. We hit the goal in July with only 8 stops. As a team, we continued to monitor our countermeasures. We closed the PDCA after we sustained the results for 3 months. Going forward, we have updated standard work instruction manual for operators. We finalized our preventative maintenance plan and included lessons learned for service technicians. Our PDCA project was presented to whole e-production team, including management, and our PDCA was shared on SWEP's company-wide homepage.